This video clip demonstrates the input and output of the dual-band telemetry system. The running yellow trace on top here is the input randomly generated by the FPGA. The pink trace at the bottom is the output of the DPSK demodulator. The blue trace and the green trace are the outputs of the integrators in the demodulator. So let's take a snapshot and take a closer look into the signal. As we can see here, the pink trace, which is the output of the demodulator, resembles the input. They're identical with a certain latency. And we can also see whenever there is a big triangle formed by the green trace and the blue trace, one cycle later, the output shows 1. When there is not the one cycle later, the output shows 0. So basically what the DPSK demodulator does is it integrates the error, every other symbol, and compares the result with a threshold. If the result passes the threshold, it interprets the signal as 1. If it's not, then it interprets the signal as 0. Now we can look at the signal here and see there is an imperfection. So because the signal here does not form a big triangle, which means the error is not large enough to pass the threshold, the output is interpreted as 0. So people might ask, if it's 0, why there should be the error? Why was there the error? And there are two reasons. One is that the transmitter is not an ideal PSK transmitter. This will be explained in another video tape. And the more dominant reason here is because in our demonstration system, our integrator reset clock is not perfectly aligned with the data transition edge. That means we have a finite resolution. So if we can align them well together, you will see very minimum difference between the blue trace and the green trace. So let's run the waveform live again and zoom out, take a snapshot. We can see the pink trace always resembles the yellow trace again. So we will explain the operation principle, the bandpass sampling theory, and the telemetry link design in another video tape.